Hey, and welcome to today's lesson on proving the side angle side postulate. The student objectives for this lesson: define SAS, and our essential question: what is SAS? So what is SAS? Well, it's another congruence test. Besides side, 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 there's other ways we can tell if triangles are congruent. SAS stands for side, angle, side. So instead of three sides, we're going to have two sides and an angle. Notice how the angle is in between the sides in the name. That's really important to using this postulate. So the SAS congruence test, or postulate, whichever one you want to use, states that if two sides of a triangle are congruent to the corresponding two sides of another triangle, and the included angle of those two sides is congruent to the corresponding included angle of the other two sides, then the triangles are congruent. What? So what exactly does that mean? Well, let me explain. So when it talks about two sides of a triangle, let's have a triangle here, any given triangle, and then let's put another triangle over here, any given triangle. Let's pretend that they're the same size and shape, just because my artistic skills aren't that good. So SAS says when two sides of a triangle, so I got one side here and another side here, when two sides of a triangle are congruent to the two corresponding sides of another triangle, which means the side in the same spot on the other triangle. So this side would be here, and this side right here would be over here. So if this side is congruent to this side, and this side is congruent to this side, that's what that first part says. And then it says, and the included angle. Well, what does that mean, included angle? Well, that's the angle in between the two sides. So the angle that's formed by those two sides coming together. And that's this angle right here. So if on this triangle the included angle is congruent to the included angle in the same spot between the other two sides, if those two angles are congruent, and those sides are congruent, then the two triangles are congruent. So we have a side, and then we have an angle, and then a side. If this side is congruent to this side, and this angle is congruent to this angle, and this side is congruent to this side, then the two triangles are congruent. And that's the side angle side postulate. Now, if I'm given that the side of a triangle, in order to be congruent to the other one, so say I'm looking at this triangle and see if it's congruent, and I know that this side is this length, and this side is this length, and that this angle matches the other angle. The reason why I don't need any more information to tell me if the triangles are congruent or not, because there's only one way to finish this other side. It has to be this length. It can't go past it. If it's any longer, that's not a triangle, because they don't, you can't have this overlap. Or if I erase that, it also can't be shorter than that length, because if it's shorter, it's not a closed figure, and therefore it's not a polygon, and if it's not a polygon, it's not a triangle. So the length of this side has to be this length. Why does it have to be that length? Well, remember that this side of this angle has to be that angle. If I make this side shorter and bring this side in, even though, yes, both of these side lengths will stay the same, this angle gets smaller. And we already know that that angle can't get smaller, that's set, right? So in the same respect, we can't go across and say, well, we'll just move this side out. Well, no, because this angle will get bigger, and we already know that it has to stay that size. So therefore, this last side of the triangle has to be this length. And since we already proved that side, side, side is true, if this side and this side and this angle make this side have to be a certain length, then the other triangle is going to do the same thing. So therefore, this side will have to be the same length. You can also remember that we talked about how angles are directly related to the side length of the opposite side. So if these two angles are the same and these sides are the same, then this side has to be the same as this side. And therefore, we already know SAS is true, so therefore side angle side has to work as well. Now you may still have a couple other questions about side angle side, so I'm going to encourage you to go ahead and watch this video by Samuel Kahn. He'll explain it in a couple of different ways, and maybe even in a way that you'll understand more. So definitely encourage you to go ahead, watch this video coming up next, and we'll be back here afterwards.
We now know that if we have two triangles and all of their corresponding sides are the same, so by side, 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 so if the corresponding sides, all three of the corresponding sides have the same length, we know that those triangles are congruent. What I want to do in this video is explore if there are other properties that we can find between the triangles that can help us feel pretty good that those two triangles would be congruent. So side, side, side works. What about angle, angle, angle? So let me do that over here. What about angle, angle, angle? So what I'm saying is if, let's say I have a triangle like this, like I have a triangle like that, and I have a triangle like this, and if we know that this angle is congruent to that angle, if this angle is congruent to that angle, which means that their measures are equal, and that angle is congruent to that angle, can we say that these are two congruent triangles? And at first case, it looks like maybe it is, at least the way I drew it here. But when you think about it, you can have the exact same corresponding angles having the same measure or being congruent, but you can actually scale one of these triangles up and down and still have that property. For example, if I had this triangle right over here, it looks similar, and I'm using that in just the everyday language size. It has the same shape as these triangles right over here, and it has the same angles. That angle is congruent to that angle. This angle down here is congruent to this angle over here. And this angle over here is congruent to this angle over here. So all of the angles in all three of these triangles are the same. The corresponding angles have the same measure. But clearly this triangle right over here is not the same. It is not congruent to the other two. The sides have a very different length. This side is much shorter than this side right over here. This side is much shorter than that side over there. And this side is much shorter over here. So with just angle, 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 you cannot say that a triangle has the same size and shape. It does have the same shape, but not the same size. So this does not imply congruency. So angle, angle, angle does not imply congruency. What it does imply, and we haven't talked about this yet, is that these are similar triangles. So angle, angle, angle implies similar. So let me write it over here. It implies similar triangles. And similar, you probably are used to the word in just everyday language, but similar has a very specific meaning in geometry. And similar things have the same shape, but not necessarily the same size. So anything that is congruent, because it has the same size and shape, is also similar, but not everything that is similar is also congruent. So for example, this triangle is similar to all of these triangles are similar to each other, but they aren't all congruent. These two are congruent if their sides are the same. I didn't make that assumption, but if we know that their sides are the same, then we can say that they're congruent, but neither of these are congruent to this one right over here because this is clearly much larger. It has the same shape, but a different size. So we can't have an AAA postulate or an AAA axiom to get to congruency. What about side, angle, side? So let's try this out. Side, angle, side. So let's start off with one triangle right over here. So let's start off with a triangle that looks like this. I have my blue side, I have my pink side, and I have my magenta side. And let's say that I have another triangle that has this blue side. It has the same length as that blue side. So let me draw it like that. It has the same length as that blue side. So that length and that length are going to be the same. It has a congruent angle right after that. So this angle and the next angle for this triangle are going to have the same measure, or they're going to be congruent. And then the next side is going to have the same length as this one over here. So that's going to be the same length as this over here. So it's going to be the same length. And we don't know, and because we only know that they have that two of the corresponding sides have the same length, and the angle between them, and this is important, the angle between the two corresponding sides also have the same measure, we can do anything we want with this last side on this one. We can essentially, it's going to have to start right over here. You could start from this point, and we can pivot it to form any triangle we want. But we can see the only way we can form a triangle is if we bring this side all the way over here and close this right over there. And so we can see just logically that if for two triangles, they have one side that has the length the same, the next side has the length the same, and the angle in between them. So this angle, let me do that in the same color. This angle in between them, this is the angle. This A is this angle and that angle. It's the angle in between them. This first side is in blue, and this second side right over here is in pink. And well, it's already written in pink. So we can see that if two sides are the same, have the same length, two corresponding sides have the same length, and the corresponding angle between them, they have to be congruent. There's no other place to put this third side. So SAS, and sometimes it's once again called a postulate, an axiom, or if it's kind of proven, sometimes it's called a theorem. This does imply that the two triangles are congruent. So we will give ourselves this tool in our toolkit. We had the SSS postulate. Now we have the SAS postulate. Two sides are equal and the angle in between them for two triangles, corresponding sides and angles. Then we can say that it is definitely these are congruent triangles. Now what about, and I'm just going to try to go through all of the different combinations here. What if I have angle, side, angle? So let me try that. So what happens if I have angle, side, angle? So let's go back to this one right over here. So actually let me just redraw a new one for each of these cases. So angle, side, angle. So I'll draw a triangle here. So I have this triangle. So this would be maybe the side. That would be the side. So let me draw the whole triangle actually first. So I have this triangle. Let me draw one side over here. And then let me draw one side over there. And this angle right over here, I'll do it in orange. And this angle over here, I will do it in yellow. So if I have another triangle that has one side having equal measure, so I'll use it as this blue side right over here. So it has one side that has equal measure, and the two angles on either side of that side, or at either end of that side, are the same. Will this triangle necessarily be congruent? And we're just going to try to reason it out. These aren't formal proofs. We're really just trying to set up what are reasonable postulates or what are reasonable assumptions we can have as we in our toolkit as we try to prove other things. So that angle, let's call it that angle right over there, they're going to have the same measure in this triangle. And this angle right over here in yellow is going to have the same measure on this triangle right over here. So regardless, so I'm not in any way constraining the sides over here. So this side right over here could have any length. It could have any length, but it has to form this angle with it. So it could have any length, and it can just go as far as it wants to go. In no way have we constrained what the length of that is. And actually, let me mark this off too. So this is the same as this. So that side can be anything. We haven't constrained it at all. And once again, this side could be anything. We haven't constrained it at all, but we know it has to go at this angle. So it has to go at that angle. Well, once again, there's only one triangle that can be formed this way. We can say all day that this length could be as long as we want or as short as we want, and this one could be as long as we want or as short as we want. But the only way that they can actually touch each other and form a triangle and have these two angles is if they are the exact same length as these two sides right over here. So this side will actually have to be the same as that side, and this would have to be the same as that side. Once again, this isn't a proof. I'd call it more of a reasoning through it or an investigation, really just to establish what are reasonable baselines or axioms or assumptions or postulates that we can have. So for my purposes, I think ASA does show us that two triangles are congruent. Now let's try another one. Let's try angle, angle, side. Let's try angle, angle, side. And in some geometry classes, and maybe if you have to go through an exam quickly, you might memorize, okay, side, side, side implies congruency, and that's kind of logical. Side, angle, side implies congruency, and so on and so forth. I'm not a fan of memorizing it. It might be good for time pressure. It is good to sometimes even just go through this logic. If you're like, wait, does angle, angle, angle work? Well, no, I can find this case that breaks down angle, angle, angle. If these work, just try to verify for yourself that they make logical sense why they would imply congruency. Now let's try angle, angle, side. Let's try angle, 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 side. So once again, let's have a triangle over here. It has some side. So this one's going to be a little bit more interesting. So it has some side. That's the side right over there. And then it has two angles. And let me draw the other sides of this triangle. I'll draw one in magenta and then one in green. And there's two angles and then the side. So let's say you have this angle. You have that angle right over there. Actually, I didn't have to put a double because that's the first angle that so I have that angle, which we refer to as that first A. Then we have this angle, which is that second A. So if I know that there's another triangle that has one side having the same length, so let me draw it like that. It has one side having the same length. It has one angle on that side that has the same measure. So it has a measure like that. And so this side right over here could be of any length. This side over here could be at any length. We aren't constraining what the length of that side is, but whatever the angle is on the other side of that side is going to be the same as this green angle right over here. So for example, it could be like that, and then you could have a green side go like that. It could be like that and have the green side go like that. And if we have, so the only thing we're assuming is that this is the same length as this, and that this angle is the same measure as that angle, and that this measure is the same measure as that angle. And this magenta line can be of any length, and this green line can be of any length. We in no way have constrained that. But how can we form any triangle that is not congruent to this? Because the bottom line is this green line is going to have to touch this one right over there, and the only way it's going to touch that one right over there is if it starts right over here. It starts right over here because we're constraining this angle right over here. We're constraining that angle. And so it looks like angle, angle, side does indeed imply congruency. So that does imply congruency. So let's just do one more just to kind of try out all of the different situations. What if we have, and I'm running out of a little bit of real estate right over here at the bottom. What if we tried out side, side, angle? So once again, draw a triangle. So it has one side there, it has another side there, and then I don't have to do those hash marks just yet. So one side, then another side, and then another side. And what happens if we know that there's another triangle that has two of the sides the same and then the angle after it? So for example, it would have that side, just like that, and then it has another side, but we're not constraining the angle. We aren't constraining this angle right over here, but we're constraining the length of that side. So let me color code it. So that blue side is that first side. Then we have this magenta side right over there. So this is going to be the same length as this right over here, but let me make it at a different angle to see if I can disprove it. So let's say it looks like that. Or actually, let me make it even more interesting. Let me try to make it like that. Let me try to make it like that. So it's a very different angle, but now it has to have the same angle out here. It has to have that same angle out here, so it has to be roughly that angle. So it actually looks like we can draw a triangle that is not congruent, that has the same two sides being the same length, and then an angle is different. For example, this is pretty much that. I made this angle smaller than this angle. These two sides are the same. This angle is the same now, but what the byproduct of that is that this green side is going to be shorter on this triangle right over here. So you don't necessarily have congruent triangles with side, side, angle. So this is not necessarily congruent. Not necessarily. Or similar. It gives us neither congruency nor similarity.
That's all I have for this lesson. Hope you learned a lot. Hope you enjoyed yourself. Be sure to go try your homework assignment. If you have any questions, give this video another watch. Really take some good notes, and if you haven't taken notes yet, be sure to go back through and do that. If you still have questions, reach out to me. Any ways is fine. Whatever's easier for you. And be sure to come to live class where we can get into this in a little more depth.